Hello everyone, welcome back to Dr. K. Primer video lecture series presenting by Dr. K. Prem, that's me. In today's lecture, we'll discuss about construction of M13mp7 Cloning Vector. As you all know that M13 based vectors are basically used for sequencing of cloned insert. So here we'll be talking about M13mp7 construction. To construct the M13mp7 vector, here we have taken M13mp2 as a base vector. In M13mp2, you can see that there is a laxed region which encodes the alpha peptide of beta galactosidase. In that, there is a eco-R1 site is created. That is nothing but GAA TTC. So to construct the M13mp7, we use M13mp2 as a base vector. Since it is having the eco-R1 site, we'll digest this vector with the eco-R1 enzyme. So once you digest the M13mp2 with the eco-R1 site, and it will linearize the M13mp2, right? So the linearized M13mp2 is ligated with the adapter molecule, which is having the BAMH1 internally and eco-R1 cohesive sites at the end. You can see AA, TTC, and G. So this adapter molecule, that's a 18 base pair adapter molecule, which is having the readily ligatable cohesive ends. And here, linearized M13mp2 is ligated with the adapter molecule. And the ligation mixture consists of vector and inserts are transformed and screened for the vector with the eco-R1 and BAMH1 restriction sites. You can see. So when they screened the transformants, they got the vector with the eco-R1 and BAMH1 sites. That vector is named as MWJ43. MWJ43. So to insert the more restriction endonuclease into the MWJ43 is again digested with the BAMH1. After digestion with the BAMH1, MWJ43 is linearized. That linearized vector is again ligated with the adapter, which is having the Sol1 and PST sites in the center and BAMH1 at the ends. So this adapter molecule can directly ligate with the linearized MWJ43 to give a you see, here you can see the adapter molecule is ready to ligate with the MWJ43. So upon ligation and transformation and screening for the vector, which is having the all the sites eco-R1, BAMH1, and Sol1 and PST1, and such vector is isolated from the transformant, that is named as the M13mp7. So now that M13mp7 one is subjected to the in vitro metagenesis to remove the unnecessary restriction sites. So those unnecessary restriction sites are present in the gene 2, especially BAMH1. Gene 3 consists of BAMH1 and INC2 and AC1, which are both are there in the gene 2. So once you remove this BAMH1, INC2, and ACC1, from the M13mp7 one, then that leads to the creation of a vector that is named as M13mp7. This is what is our goal final vector. So as you all know that when you have started the vector to construct the M13 as a vector, it has only one origin of replication, but the rest of them are created. So you can see this is the origin of replication, and the second one is the promoter. Lack open promoter to transcribe the lag Z prime region, and MCCS created where EcoR1, BAM-H1, SOL1, PST1, and there, and lag Z is there to screen the recombinants from the non-recombinants, and you can see MCCS and lag Z. And also finally, the fifth point is that unnecessary restriction sites were removed from the this vector, so that only unique restriction sites are present. M13mp7 is a symmetrical vector. Why we are calling a symmetrical vector? Because when an insert is cloned using BAM-H1 or SOL1 or PST1, but you can release the cloned fragment using the EcoR1 site. You can see EcoR1 sites are at the borders. So whenever you clone with the BAM-H1 or SOL1 or PST1, but still you can release the insert by using the EcoR1 sites. Hence, M13mp7 is called as a symmetrical vector. In the next slide, we can see various vectors and their features. Here I have compiled. You can see here basically M13 genome is the basis for construction of M13 cloning vectors. M13mp1, where in this vector, lag Z prime region is inserted in the intergenic region of M13 genome. So lag Z region, which encodes the alpha peptide of beta galactosidase, that encoding region is cloned into the IG, that's the intergenic region of M13 genome. With the addition of lag Z prime, then the recombinants, means whenever you clone your gene of interest into the lag Z, then recombinants will be white and non-recombinants will be blue. So to select the recombinants, so this criteria, this feature is useful. Then coming to the M13mp2, it doesn't, M13 do not have any unique restriction sites for clone. So that too, they are not there in the lag Z region. So EcoR1 site is created in the lag Z prime region. So EcoR1 site is created in the lag Z region. So when you use the EcoR1 site to clone into the lag Z region, then only recombinants will be in the white color and non-recombinants will be in the blue color. So EcoR1 M13mp2 provides the restriction site in the lag Z prime region. By using that, you can clone your gene of interest, and recombinants can be blue in color and non-recombinants will be the white color. M13mp7, where here MCCS, that's a multiple cloning site, is expanded. So when you compare the M13mp7 with the MP2, MP2 have only one restriction site, but M13mp7 have EcoR1, BAM-H1, SOL1, and PST1. So here you can clone the DNA fragments with the similar hands, and the MCCS is big, and they have a symmetrical restriction sites. So if you clone with the BAM-H1 or SOL1 or PST1, that insert can be released by using the EcoR1 site. Then the next vector is M13mp8, where here some of the EcoR1, SMA1, BAM-H1, SOL1, PST1, and IND3. In addition to the EcoR1, SOL1, and PST1, SMA1 and IND3 are added, so that here, and it is not a symmetrical one. You can see they are unique. So insert DNA can be cloned with the dissimilar ends. It provides a directional cloning. So you can one insert can have a two different restriction size end that can be cloned into the M13mp8, and it is useful for the directional cloning. Then M13mp9, where the MCCS is reversely oriented. So here, in case of M13mp8, eco arm is close immediately after the promoter. But when it comes to the M13mp8, Hind 3 is the very close to the promoter. So it's a reverse orientation of MCCS and directional cloning. And the M13mp8 and M13mp9 both are useful for the sequencing of a cloned fragment. In one way, when you cloned in mp8 and the same clone is cloned in the mp9, then you can sequence from both ends and you can view the complete sequence of that insert. So this is all about the M13mp7 and other M13 vectors and their application. So try to subscribe my channel. That's a Dr. K PREM-PRIMER for more updates. And if at all if you wish to share the video, no issues. And try to give thumbs up when you like it. And if you have any comments over the content, please write to me through the comment section. Thank you all for listening. This is your Dr. K PREM. Bye-bye.